Our next speakers, Eric here, he founded Tool US, started many hackerspaces, and worked in the US Department of Energy, developing attacks and defenses for tamper-evident seals. Now he runs a physical security company called Rift Recon. Ryan has launched the data haven Haven Co., built satellite wireless networks in Iraq and Afghanistan. And now he runs a trusted computing company, CryptoSeal. Together, they've been developing novel seal and cryptographic technologies to thwart physical attacks on computing devices, such as what you'd find from an evil Maid. So, I turn it over to you guys.
Awesome. Cool. Yeah, it's on.
Yeah,
awesome.
Thank you very much.
Thank you. Thank you, Christy. And Christy, also, I look forward to when you pass the bar. We're old friends. So, and when you do, first drink's on me. All right, so let's get started. So this is Thwarting Evil Maid Attacks, physically unclonable functions for hardware tamper detection. My name's Eric Michaud, and this is Ryan Lackey. In case hair, no hair. You can separate us during the talk. It's easy. Anyway, so let's get started. So what are we going over today? First off, what are evil maid attacks? And then we're going to go over who is at risk. It turns out everyone in this room is probably at risk at some point, more so than they were a few years ago. How is it done? What are the methods of attack that are common and more esoteric? And then how can we be safer? And what new seal technologies are coming out that you can implement yourself? So, all right. So, yep. Here's a little bit about here's my CV, just a little bit of it. I was the co-founder of Tool US. Some of you may know, some of you might not know. I started Tool US in 2004, and I co-founded a few hackerspaces in Rift. I'm really, I don't really have any engineering degrees, but I am a self-taught engineer, a machinist, a hacker, and now an actual CEO. I have staff I have to look after and have great responsibilities. I've always been a breaker of physical systems. I love breaking things. I've figured out attacks for multi-locks. Some of you might be aware of Medico, certain alarm sensors, and many other high security systems, including voting machines. While I was at Argonne National Lab, we did the verification of the voting machine hacks from Princeton University, and we invented a lot of new stuff there too. And also now I'm currently, through a partnership of Rift and Exploit Hub. Some of you don't know what that is. It's a non-ODay site. We're building their whole hardware directory. So check it out.
I'm Ryan Lackey. I started Haven Co. with a couple other people back in around 2000. It's the world's first offshore data haven in the North Sea nearby. I worked on anonymous electronic cash payment systems using blinded protocols. I'm a security consultant in payment technology and cryptographic hardware. And I founded a satellite and wireless networking company in Iraq and Afghanistan, so a pretty high-threat environment back during the conflict. And I also operated US military medical imaging systems in Iraq, Afghanistan, and Kuwait. And now I'm one of the co-founders of CryptoSeal. We do trusted computing technology development. And we actually ran a VPN provider for a while. It was a consumer VPN. We were just using it as a sort of a demo of some of our technology. And when this whole LavaBit fiasco happened, where they were compelled to disclose their keys, we preemptively shut it down because our current system wasn't resistant against it. But we're working on a system that actually will. So hopefully next year we'll have something great in that regard.
So stick around. So what is an evil maid attack? An evil maid attack is an attack performed by a trusted entity, specifically in the hotel industry, if you will. You suspect that the maid that comes to clean your room is someone who's benign, but in fact often they're used by nation states, intelligence agencies, or corporations in many cases where it's really their staff, and they come in to really clean up, so to speak. American idioms aside, but bug your laptops, steal intellectual property, or any number of different things.
Yeah, and I would say these really came to mass knowledge in the security community back in 2009 when Johanna Rakowski from Invisible Things Lab published a paper about attacking TrueCrypt using invisible maid attacks. And that sort of shows one of the interesting things about these attacks is they have some unique characteristics. They're a way to get persistent access and pivot to other systems, and they bypass a lot of conventional defenses. A lot of the things that you've already built for security make certain assumptions about the integrity of your physical hardware, and they just sort of like hand wave away, say if somebody gets access to your physical hardware, all bets are off. But the problem is people get access to your hardware all the time. So it's really not very helpful to say, if they get access to your physical security, we're not going to help you. So we had to come up with some stuff, and the security community needs to come up with things that will work in that environment.
So who is at risk? Originally, it was government entities, intelligence community, or major criminals. But nowadays, it's travelers with business, science, and engineering, and intellectual property. How many of you in the room? I mean, some of you are young, so you might not be working at a large company, or even not that you want to, but working in an area where you're developing something that's unique, that's valuable. Raise your hand. Whether it's source code, actually pretty much all your hands are up. I don't have to explain any further. So
it doesn't even need to be a company. It could be your academic research. So people that are PhD students or working on anything, or even a personal project that somebody wants access to.
You don't have to tell us, but how many of you are activists? Raise your hand. Some of you, OK. This is definitely relevant for you. How many of you play poker? I know some of you have seen PokerStars bags going around, but are online gamers. In some way that you deal with cash or some other value exchange. Cool. And journalists, some journalists in here? Yep, let's see a few hands. And people who have lived or are living.
Or have family members who live in war zones.
So I'm going to see a few hands go up. OK, yeah, you guys are actually at risk. It's no longer the people at the top of the food chain. So what changed?
Yeah. So really what's happened is, it's a few things. The government sort of has changed its focus. It used to be that intelligence agencies' primary adversaries were other major state intelligence agencies. Now, most of the big intelligence agencies are focused on small groups, terrorists, non-state actors. So they've developed a lot of technology that's sort of targeted on that kind of smaller threat. People travel internationally a whole lot more. It's really cheap. It used to be expensive and difficult, but we flew here from the US for this conference. A lot of people fly across international borders all the time. And it's pretty frequent. They also carry a lot of vulnerable stuff with them. It used to be you'd travel with maybe a physical notebook and a pen and maybe a film camera. And now you travel with laptop, cell phone, tablet, e-reader, camera, fitness device, flash drive, all sorts of stuff, and just in one bag. So people carry a lot of stuff around with them.
And items that actually carry a lot more information than just a notebook.
Yeah.
So it's a lot easier to do, too.
Yeah. In addition to the nation-state threat, there's a lot of ways that commercial entities can now make a lot of money by compromising accounts. In the news, there've been a bunch of big attacks on major retailers where huge numbers of credit cards were compromised, all sorts of compromise. So it's very profitable now to have a commercial or criminal organization attack.
Yeah. Also, if you get first to market when a new technology is about to come out and you beat them to it, you get first mover advantage. Yeah. So the thing is, it really pays to not pay for research, it turns out.
Yeah. So it's a pretty scary world.
Yeah.
So to illustrate this, we've come up with some scenarios on exactly how users can be attacked while they're in various environments. So we've got business travelers that are doing international travel. We've got activist organizations, the gaming user, journalists, and people that live in war zones. And we'll go through those and describe some security threats they face, some conventional countermeasures they have, and how those countermeasures are defeated through physical attacks. So first up is the international business traveler. And it's not really an executive necessarily. It could be anybody. It could be a student. It could be an engineer. Actually, engineers and scientists are among the main targets for this right now. And one of the things they do is they carry a lot of intellectual property on their device. They have source code. They have research findings. They have everything else. So there's information that the adversary wants to steal from their devices. There's also, they access systems back at home. They keep online to keep working, because it's kind of crazy to go on a vacation or a work trip and not have access to your systems. So they can attack your system while you're in a country and use that to attack your systems back at home. And the scariest thing is they can actually attack your device while you're in a country and leave something on the machine, you take it back to your home network, plug it in, and it keeps attacking your home network, which might be protected. So that's a pretty big threat. One of the unique threats that these people face is border checkpoints. So in a lot of countries, you have pretty good rights and personal liberties when you're inside the country. In the US, in the EU, lots of other places, UK. The problem is, at borders, a lot of those rights are either limited or suspended. And as we've seen, it's pretty scary. So they can require that you turn over a machine to them for a certain period of time, and they'll give it back to you. They can require that you type stuff into your computer and all sorts of other stuff. So you might think, oh, I'm just going to encrypt all my drives. There's an obvious attack to that. They just tell you, you must decrypt it. And if they're pointing a gun at you or holding you in a checkpoint or something, you can't really say, no, I'm not going to do it. I mean, you can, but it becomes a legal challenge. Yeah. And once even if they don't get your encryption key, they just image your drive. So they've got an encrypted image, and then they can go out and get your key later and decrypt your data there.
Yeah, and that can be done through any number of different methods, whether through video surveillance or other types of ways of deriving that key, or just brooding it over time.
Yeah, especially on something like a cell phone or something that you're accessing all the time. You're going to use a pretty short passphrase. Another threat is the hotel maid, sort of the origin of the term evil maid. So you rent a hotel room. It's expensive and small, and you might want to have somebody clean it every couple of days. So the maid will come in. They have access. They don't have to wait for you to give them access to the room each time. There's a door lock, and the maid has access, either a master key if it's a conventional system or another digital key. And they can come in, and you're gone, and they know you're gone for a while. You keep a travel schedule. They know you're out at a restaurant, or they know you're in a meeting or whatever else. So they know you're going to be out of the room for a certain period of time. And the threat is not so much that a maid becomes evil, it's that an evil person becomes a maid. An intelligence agent or...
True story.
Yeah.
True story.
Yeah. So in a country, Pacific bordering country, actually a couple of those, the nation-state's intelligence apparatus will send people into your room and image your drive while you're out if you're there for meetings, and it's pretty widely known. There's a lot of problems with that. They can attack your machine. They can also attack the room. So they could bug your room. And they have some control over what room you're assigned to. So there's a pretty big vulnerability there.
So you might think that you can use a safe, though it turns out there's a lot of problems with those, like master codes, ways to bypass. Like on this safe right here, the bottom right of the panel, there's you see a little off-color, circle. That's actually a bypass key. So if there's a lockout, like the battery fails, or some other mechanisms inside is not performing correctly, you can pick that. And all hotel safes are not rated by any security standard that I'm familiar with. They just say it's secure. So it doesn't have any time to attack, takes 15 minutes of tools. They're not really that good. And you can also take the panels off, do something called spiking, which is you pull the wires out to the solenoid, because they're usually electronic, not mechanical anymore, and you just connect a 9-volt battery, and it pulls the solenoid back, and then you're in. And there's a number of other ways, too.
Another threat, which was recently in the news, is the implant. So as we said, they can image your device when you're through a checkpoint or whatever else, and they've got an encrypted image, but they need to get a passphrase, or they need to get physical access. They need to get logical access to the machine and do various other stuff. It's very difficult to detect hardware changes on physical hardware. There's a variety of them that you can go over.
Yeah, to be honest, how are you going to run antivirus on that keylogger on the left side? Honestly, what if you have a firmware updated for your Ethernet card? I mean, there aren't really a lot of technologies available immediately today commercially to solve these problems. Also, what if someone removes the keyboard, puts a single layer PCB with a VIA that logs your keystrokes and just transmits it over RF? There's many different ways to do it, as many different tools are available in your electronics catalog, and stuff that you can come up independently if you have a lot more resources, like coming up with a tool on the right called the Cottonmouth.
Probably doesn't cost $20,000 a unit to do this commercially.
Yeah.
Another threat that you face is, of course, network monitoring. You're in a country where the cell phone company is most likely either an organ of the state or is highly licensed by the state. So they can see a lot of traffic there. They can do over-the-air upgrades. They can do all sorts of stuff to your cell phone. They control all the wide area network access. They can monitor there. They can do stuff at firewall. So you might think oh, a VPN is a great solution to that. And it is. I mean, I love VPNs. But they're not so great if your endpoint's compromised. So the countermeasure you've put in place to protect you from network monitoring doesn't protect you if your endpoint gets compromised. Yeah. So another organization that has a lot of things to fear would be an activist organization. Say a group that gets a lot of highly sensitive documents given to them, or they acquire them somehow, and they're controlling them, and a lot of people really would like those documents. So they need to do things with them, and it's pretty dangerous. So they have access to documents. The adversary would like to get access to them. Also, knowing all the personnel that are involved in the organization is a big risk, because some of those people might not be public about their involvement with the organization, and if they're exposed, they might lose their privileged access, all sorts of stuff like that. Subversion of the systems of the organization, and potentially prosecution, persecution, all sorts of bad stuff can happen to you. And it doesn't have to happen in your home country. It can happen in a lot of other places. One of the unique problems that activist organizations have is they're usually pretty poorly resourced. They don't have a lot of money. They don't have a lot of dedicated hardware or anything else. There's a few that have been raising a lot of money recently, but in general, they're, especially outside of IT, they have very bad IT. Your average like labor organization group or whatever has very minimal computer security and resources for that. So they're using a lot of their personal machines with no real security policy, no real full-time sysadmin, nothing like that. They're certainly not a full-time security guy. So it's pretty easy to compromise an end user in one of these organizations. You just sort of put up a site that attracts users from that site and compromise them there. And once you compromise their computer, then you can access the systems of their organization. They also face a fairly unique problem that you're familiar with at their physical premises. So
yeah, so black bag operations are generally B&E, breaking and entering operations. So you need to get physical access some way, and that can be either picking a lock, going through a window, bypassing alarms and sensors and switches. Like, I'm uniquely familiar with this, as my company teaches the defenses and offenses of it, so we know what to look for. And there's many, many different ways you can do it. I mean, one of the things I learned years ago is, like, it's great to have a carpenter on staff because you can cut through drywall and repaint it very quickly, and no one knows you didn't touch the RFID reader. How many of you have worked in data centers where there's no steel wall in between the drywall? Yeah, I see a few hands. I'm pretty sure a lot more than you think. I've seen quite a lot of data centers in my time. But yeah, there's a lot of ways to do it. I mean, even triggering request to exit sensors is an example. Turns out you can put a little pocket warmer, when you go skiing or snowboarding, you open up a bag, it heats up, keeps your hands warm. Push that under the door, you'll trigger the inside sensor to release the door lock from the inside as if you're a person leaving. So there's many ways to do this, and I just covered a very small percentage of them. But it's a big and real threat. And
I don't think your average activist organization is going to have a super high security physical office because they'd rather spend their money on activism rather than physical facilities. Another class of users that are vulnerable are online gaming users. So this is really anybody who's got an important online account. It's not specific to gaming. But one really, really interesting example recently is F-Secure came out with a report that a poker player likes to play poker a lot, was in Barcelona. And this was back in December, actually earlier in this month. And he would play poker online. He'd also play physical. So he left his laptop up in his hotel room at sort of like a physical poker competition, went down, was playing poker, and people were compromising his laptop and installing some subversion software on his laptop while he was away. So his online poker accounts got compromised. Yeah. And the really scary thing about this is not that it's happened once. It's that this, they say, was not the first time, is not particularly unusual, has a purely commercial profit motive, so it's sort of like a self-financing operation. There's no reason to believe this doesn't happen frequently and on an increasing basis. So one of the things that people think about, if you're an evil maid, you have the cards and keys to get in. But what if you're not, and maybe you know a local locksmith, or you can bend some metal, you can do something like this with the under the door tool, where you don't need to touch the locking systems at all. You just grab the door handle from the inside. This is about a minute.
Yeah, it's about.
So you can talk to her?
Yeah, so what I'm pulling out here actually is a little wrap of steel with a cable inside, and that's called the under the door tool. It works on lever locks, so the handles with the lever. So that one's all wound up. We undo the Velcro and then shove it under the door. I actually have it over there. Actually, Starbug, who did the Touch ID hack, actually, I have to give one to him, so you guys can keep one here in the country. But yeah, if you want to see it later, come by the locksmith area. Or sorry, lock picking area, and we can do some demos. But yeah, checking to see that the door is open or locked, because sometimes it's actually left open. Measure the distance. Slide it under the door. You see in the top left, the tool going in. Lifting up. 1, 2, 3. Almost on the handle. And that's it. And once I know it's there, pull the wire, jiggle. And I'm in.
So another class of users that we care about that are at risk are journalists. And there's a lot of definition of who's a journalist, but really anybody reporting on this kind of stuff at this point is doing journalism. And journalists often are very public people, so they themselves are known, but they have confidential sources. And the reason why these sources are willing to give information to the journalist is that the journalist protects their anonymity very, very strongly. There have been journalists that have gone to prison for protecting to protect people from being compromised, and certainly and worse in other countries. So this is very important to journalists, and there's some attacks that are pretty unique to journalists. Like, well, not terribly unique to journalists. You basically just arrest them, and you have them, you seize their equipment, and you image it, and you give it back to them, potentially with malware installed, or if they didn't bother to use crypto, because the majority of them don't, you've got the data there. And they're usually not very rich, so if you seize their equipment for a couple days, they're really worried that they're not going to be able to get any work done when they get it back. So they're not going to go out and throw it away and go out and buy new hardware. They're going to take that equipment and keep using it as if nothing had happened, and yeah, you win. So, yeah.
Yeah. And if there's no evidence that it's been tampered with, it's going to be really hard to pressure your boss to get you a new laptop.
Yeah, that's if you're not independent.
Yeah, if you're not an independent stringer, yeah.
Yeah. And then the other category of people are people in war zones, and that's really the whole range of people that are just sort of like families that live there. If you've got a relative who happens to live in a country that becomes a war zone over time, they're at risk because both your personal physical safety is at risk. I mean, obviously it's a war zone, and going after contacts and networks. You want to find out all the people that are members of certain organizations. You find one of them and you sort of like do a network analysis and find all the people they talk to and all that stuff. And there's a fairly unique problem for people in these places where people on both sides are in Middle Eastern countries that are in war zones. They will find somebody who's in a network. They will compromise that person. They'll imprison them. They'll kill them, whatever else, take their systems and continue impersonating them, and find everybody else who's in their network, attract them, and arrest or kill them. So it's a huge risk for them. It's pretty much the ultimate risk. So you'd think, as we said earlier, the governments were sort of the original people that faced these kind of risks, and they had some solutions. But as we'll see, they had solutions, but they were really just for government. They're not really applicable to a lot of other people in a lot of cases, and they're not really foolproof either. So government security is certainly not a bulletproof thing. One of the things they've always built on is they have is physical security. Governments have long, like way before computers, relied on physical security to keep their records, facilities safe. They have a bunch of standards. I'm familiar with the US standards, but a lot of countries have these things, where if you're going to use a computer at a very high security level, you can only do it in a special kind of environment. You don't go to a coffee shop with your laptop. You don't go to a regular office environment with a laptop to process. You do it in a room called a SCIF, a Sensitive Compartmentalized Information Facility. It's basically a bank vault that is lined with some metal to block RF shielding, has physical security, so it's got very high security locks, monitoring, alarming, everything else. Super expensive. Like the seals on the doors alone are like 5–10 grand. So you're not really going to buy these commercially. They're restricted. A lot of the standards are actually themselves classified in order to build one of these things. They're required for defense contractors in America. It's a big deal. One of the things they have actually are embassies. So they actually were able to get all the other countries to come up and do some treaties. So there's Vienna and other places where they decided that all countries' embassies would be sort of inviolate territory of the country extraterritorially. So they will not be able to be subject to local search or anything else, which is great, because a great way to defend against search is to just not be allowed to be searched. Unfortunately, like private citizens can't really do that. They have special couriers that will transport material between sites. They run basically their own courier service. Sometimes they use commercial carriers. Sometimes they have armed security guys that travel with the item and keep it protected that way. They've got a lot of other stuff. But basically, the fundamental thing here is all this stuff is really, really expensive. I mean, one of the things they do that's sort of like the least absurd thing they do is they have a dedicated travel pool of laptops that are the only machines that are allowed to be taken out of their facility. So if you're a government user that wants to go to a foreign country for a conference, you don't get to take your work laptop. You take a special laptop that only has access to very minimal things, doesn't have access to home systems, everything else. That works great if you've got like 500,000 employees and they don't really need to do a lot of work during that trip. But if you're a private person who travels to a country to do work, you have to take your stuff with you to do all your work while you're there.
Quick question. Quick test. Quick question. Who travels for work with their laptop? Everyone should look around really quick.
Yeah.
A lot of hands up. No, don't keep them up, so don't hide it. Now look around. A lot of you do that, yeah. That wasn't happening about 20 years ago, FYI. Just like that, the landscape has completely changed.
Yeah, and they do some cool stuff with those travel laptops. They actually, when they get them back, they do various forensic analysis on them. Sometimes they do physical inspection. Sometimes they X-ray them to see if components have been added to them. They do all sorts of crazy stuff on these things, depending on who they are. Like certainly, U.S. agencies usually have more money than a lot of countries do, so they're going to do more of this stuff. And if they're going to a high-threat environment, they might do more than if they're going to a friendly country. But they do a lot of stuff that's really difficult to do. And they have so much money, they can build their own custom procedures, they can implement great policies, and government employees are really good at obeying directives and doing it persistently and consistently. So they can have a policy where they have to go do something every day, and they'll actually stick to it. But yeah, custom hardware, detailed accounting procedures, everything like that. Okay. Problem is, it's not completely effective. So it's super expensive and doesn't actually work.
It turns out certain organizations, when they come up to problems like these, they develop specialized tools. So as I said at the very beginning, I'm the co-founder of Tool US. I've been a sport picker for a long time. Then I worked for the United States government, learning more stuff and how the mindset worked of like, you need to get access into these hardened areas. I never worked on those particular problems, but I learned around that. And eventually started learning about other tools. And there's a man by the name of John Fall who makes tools not generally for the public market. He makes lockpicks for the public market, but he came up with this particular tool about over 20 years ago, I've been told. It used to be a classified tool. I don't think anyone has seen this ever in public. And so this is basically, we're dropping this right now. This tool right here is called the Universal Pin Tumbler Decoder. You can come by the lockpicking area later and take a look at it. Basically, what it does is it is designed to not pick a lock, but decode a lock. This tool, what it does is it has a very thin wire shim. It doesn't lift the pin. It slides between the pin and the cavity. And it curves back. And you can see, I don't know if you can see it very well because the wire's so thin, but stop by the lockpicking area. We'll have more videos online in a bit. This tool is no longer classified, so I'm not going to get in that kind of trouble. But the tool, I turn up the hypodermic syringe, which carries a needle. There's a little wire, and it slides up, and you can see at the top pin, it might jump a little, see it spins right there? That means I touched it, and I'll feel that on the plunger. And when you train enough with this tool, you can decode locks down in as low as 30 seconds. And the other interesting thing is, to the design of this tool, is that you can come back years later as long as the lock has not been repinned. So if you only have time to, like in a dark corner, go by and try the first pin, you figure it out, go away, tell maybe one of your other black bag operators and say, okay, I got this one, do this one. And if you only have 10 seconds at a time, you can do that, and then eventually you'll have persistent access because you will be able to cut the key to code after the fact. So these are tools that are, as I said, not available to the public market at all, heavily restricted. Hell, I can't even really buy them, but I do have one from a friend. And so I thought it would be interesting to show the public what kind of tools are available. Now, I said this is 20 years old. There are way more sophisticated tools today to give you some perspective as to what is available. As you've been also seeing through the other talks, there are other tools that most people didn't think existed.
And there's other tools the other thing that's unique about government is they are willing to spend a lot of money to go after a single target. In the case of the US and the Soviet Union back from, I think, the 50s or 60s, US built this great embassy in Moscow, and they got a gift from the Soviets of a seal, a great seal of the United States. It was really, really pretty. And they thought, oh, does it have a microphone inside it? It had no active components or anything else inside it. It was just this nice seal. So they hung it up in one of their sensitive meeting rooms. And it turns out it actually had a piece of metal inside it that when you irradiated it with RF from an outside thing from one of the Soviets' facilities, turned it into a microphone that would remotely transmit a thing. So they spent, I don't know how much time coming up with this thing for a single room, single attack, but pretty effective. And there's no reason to think they haven't continued doing that over time, given the $50 billion budget for this kind of stuff every year. So it's pretty crazy. And the other reason why, so there's these weird technical things. So those are the advantages government has, but they also have some disadvantages. One of their big disadvantages is actually their other strength, is that they're so big and they have so much money and so much staff. That means they've got a lot of insiders And one of the biggest risks to them is that they have insiders that are going to either accidentally not comply with security policy or willfully not comply with security policy. And pretty much recently, we've seen some of the consequences of that. So they have that threat, whereas an individual certainly doesn't have that threat, and a small organization generally doesn't have that threat as frequently. And sometimes they just screw up. Like the US Commerce Secretary went to China on a big meeting. They did everything right most of the time, and they just sort of like left a laptop containing the Commerce Secretary's left a bag containing his laptop like somewhere. And yeah, so if the problem is they have to be right all the time, and if you screw up once, that's not so great.
So where do we go from here? We have all these types of attacks, and we think we have all these defenses, and it turns out they're really not that good, especially when you don't have a well-resourced entity to take care of having a dedicated security staff to train employees and everything else. Well, there's SEALs. Not this SEAL. These kinds of SEALs. So SEALs come in many shapes and sizes. I have a particular way of describing them, but where I used to work at the vulnerability assessment team at Argonne, they have a great description of tamper-evident devices. And I'm just going to read it right here. So tamper-evident devices are used to detect and report an unauthorized entry. So that's how you get an idea of what it is. And perhaps discourage it. Unlike intrusion or burglar alarms, SEALs report unauthorized entry after the fact. They must be inspected either manually or electronically. So they can be, tamper-evident tapes, stickers, seals. Like the peel of an orange is actually a tamper-indicating device. If it looks like the wrong color, then you don't eat it. That's its job. But it didn't help you prevent that. And they also, so a SEAL does not need to resist a physical entry. Actually, it's supposed to be broken, but it's supposed to indicate to the person that it has been opened. In other words, a SEAL is not a lock. Indeed, some SEALs are made of paper or plastic and can be easily removed or cut off. Certain security products known as barrier seals, they do provide a physical barrier to entry, but again, they're not also very often reusable. These are hybrid devices, part lock and part seal. Barrier seals should be used with care. Barrier seal is often a compromise of a product, neither optimum as a lock or as a seal. It's a dual function tends to complicate issues about how to best use the product. So whether you use it like on a laptop or in your car or on a shipping container, et cetera, et cetera. SEALs also require very strong procedures to be put in place to be effective. If you don't have a policy of having someone check and actually checking things, not just looking at it, but seeing that the serial numbers line up, does the device look like it's been messed with? Did it peel back? Did it change color? Any of these different factors, if you're not checking for those things, which can take it and require a trained eye, they're not effective. And so you need to have procurement and storage and record-keeping procedures to make these things work. So anyway, turns out physical seals also really suck. Aside from having what you think are good seals like you see them on the market, it turns out that there's an event at DEF CON called the Tamper Village, and people have been taught in the last few years, and now there's competitions about how fast people can defeat these seals. As you see on the table over here in the picture, you'll see a lot of plastic wraps and beads, and those often are defeated by shims made out of Coke cans or beer cans. People also use solvents for the paper materials and plastics like heptane, acetone. A lot of these things are over the counter. And it turns out that it doesn't take a very long time to defeat seals. The VAT did a study over the years, and they keep adding to it as they do more seals that they haven't seen. But as you can see here, the average time to defeat average seals, even high-end ones, is around 1.5 minutes. And the median is even less than that. Like a lot of them I can defeat around that time frame myself, and I teach that too. And now I know the defenses for these. And it turns out it's not really expensive to do so. Some of them are really expensive, but yeah.
So there's another problem is that users are lazy. This requirement that seals be verified by the user and have a big security policy and everything else. We've got some sort of analogs in the regular computer security world of things like SSL certificate checking and SSH keys and everything else. People just click through. They don't really put any effort into it. So when they've got a choice, they're gonna skip ahead. So it's really unlikely we're gonna build a great system that depends on users making correct security decisions all the time. There's another feature that'd be really nice, remote attestation. It'd be nice, like this whole cloud thing with like remote services and all these other things. It'd be nice if the cloud service that actually had your data knew that your laptop was secure before you connected to it and did all this stuff. So you need a way that your computing device can prove to the remote server, either your organization server or a commercial service or whatever, that it's actually intact. There are devices that do this. The problem is they're not really ideal. One of the classes of devices is something called a hardware security module. They are basically computers inside little safes. They've got tamper evidence all over them and tamper response. So if you try to mess with them physically or logically or anything else, they erase the contents before you can get to them. The problem is they're like $20,000 each. And there's maybe 2 or 3 big manufacturers of them, and they're big defense contractors / government vendors. So if an activist organization were to try to buy one on their website, 1, they probably wouldn't get one because they're export controlled. 2, if they were having one shipped to them, it would be one of those packages that would get sort of like mysteriously delayed for a couple of hours and replaced with one that's actually evil. So they couldn't trust it. And they're so expensive that no one's really going to do like a teardown analysis of a $20,000 device where you've got to burn like 5 or 6 of these devices and everything else. Like no private organization is going to, like no private individual is going to do that. And you can't really trust like a standards agency to do this for you. Yeah. So there's also smart cards, which are great. They're cheap. They're in all your cell phones as SIM cards. They're in ID cards. They're in payment cards, everything else. The problem is they don't actually provide enough physical protection for this threat model. They provide protection for individual credentials, but in this case, if you compromise any of the systems, you're going to compromise all of them. So it's not so great. There's also trusted computing. So it's the TCG, TPM, TXT, all these acronyms from people that have been really around since like the mid-late 90s. It's inadequate. It's inadequate for a few reasons. 1, not really widely deployed, doesn't really work, but maybe we can fix that. But second, it doesn't protect the whole thing that you need to protect. It was designed to do basically DRM, digital rights management, to keep people from pirating movie content. We can see how well that's worked. And it's not really designed to protect a single machine, a single computer from a focused attack. You can still attack the memory, you can attack all sorts of stuff. So it's insufficient, and it's a pain. So it's not really a great solution either. And certainly it's not a great solution if somebody has physical access to your machine to do stuff with it.
So where do we go from here? People think it's a good idea to take a notebook, write down things, and check it, but it's not really objective. You need machine verifiable and repeatable tests. So quick quiz for the audience. Who can tell me what is different about these 2 pictures? Raise your hand and I'll point you out and you can yell it. Anybody? No, seriously, like it's audience participation. Anyone? Just shout it out. What's different? No one? I know, it's kind of hard up here. OK, maybe this will be a little easier. There's a technique called blink comparison. What's changing now? Can you see it? Right. Yes, the screw. This is a simple technique you can use, developed by astronomers many moons ago. And it makes it a lot easier for you to tell that something's changed. Like, you can't just say, I turned the screw 38 degrees. It's just not going to really cut it. Unless you have a method with photography, like a mobile phone or some other device. It's just, you won't know if something's been tampered with or it's just you're paranoid, even if it's true. So where do we go from here?
Yeah, so the problem is, so this is a great check. And if you use a cell phone to do this check, it's easier to do, cheaper to do, everything else.
What? Someone shouted?
Oh, okay. Okay.
Never mind.
So it's easier to do. But the problem is it doesn't really address the problem of users are pretty lazy. What you do is you'd ask a user to say, are the seals intact on your machine before you log into this website? Please check this box if it's secure. Yeah, you know how well it's going to work. So what we did is we came up with a way that we could make the seal verification basically like a 2-factor authentication. So it's a machine check that then sends something to a remote server that's located in your home data center, verifies the integrity of the seal, and then sends you back a short-lived credential. Right now it's a Kerberos ticket, but we could do SSL cert. We could do all sorts of stuff or just allow you access to the resource. And this basically makes it non-skippable by the user. If the user doesn't do the check, they don't get access. Pretty fair. And it works great. It's cheap. It uses cheap seals. Uses cell phones that everyone's got with them. The cell phone is considered to be secure because you have it with you at all times. and it can protect in a lot of these scenarios that we've outlined. You can go through the business traveler, all these people.
Yeah. So how would you apply these things to your own devices? So first off, with the business traveler, nowadays people are starting to make USB port plugs, like ultra port plugs, like in your ThinkPads. What you want to do is put them in. They disable the port physically. You'll have to disassemble the machine. So if you're putting tamper evidence stickers over all the control surfaces, which are areas that you can open to get internal access, it's a good start. Then again, you got to make sure you have a tamper indicating device that is very frangible. You don't want something that could be peeled back and put back very quickly, unless someone doesn't know that that actually is a tamper indicating seal. Maybe you just have your EFF sticker as an example on there, and they think it's just decoration. But really, it's to tell you that something has happened. And then activist organizations at their headquarters, maybe just putting, a pen on a table in a particular way, and then you photograph it. You have to do like a photograph. You can't just say, I placed it there. You're really going to miss stuff. And so what you do is to get access to, let's say, a filing cabinet, you maybe have to move something. And if they don't place it back directly, you'll know something has happened. Someone has been there. Just make sure if it's something light like paper, you don't have a fan blowing around and just knock things over. It'd be useless. Online gaming user, you can use the safe, but you should use seals in the safe. I didn't really cover covert traps, but covert traps are your secret tamper indicating devices, like a piece of hair, like you put it on a door jamb, lick it, place it. It's very hard to see, very hard to detect unless someone knows to look for it. But then you have other seals around just as distraction, but they also are covering important parts. Journalists operating in dangerous environments, they're kind of the same thing. But also, if you're going to go meet somebody in a particular area, you clear it ahead of time. You go check out, maybe you're going to be in a room where no one will be, but you want to make sure that after the time between you clean it, clear it, check it, and you come back, no one's been there. So you put seals on doors, maybe you move a chair in a particular way so that you can check again with a photograph.
And for people living in war zones, one of the ways you could use this would be when you're sending information or sending physical items to people, you put them in a sealed container that has seals, and you send them out of band through email or through some other means the integrity information for that seal, so they can verify that the package hasn't been tampered with when they receive it, so they know it's actually from you. It's basically a way to cryptographically sign a physical item, which is kind of cool.
Yeah.
The problem with all these, the seals we think are a great solution to this, but they've got some definite problems. The biggest problem is they can't go back in time. You need to, if you've got a device and you just show up with a new device and you ask me, like, is this device tampered with? There's no way I'm going to be able to give you a good answer because there's so many ways you can tamper with something. If you don't have a good baseline measurement on that device, you won't be able to compare it to anything. So you'll be trying to find like vendor specs for it, but there's errata. It basically isn't going to work. I would just tell you, buy a new device. And most of these devices, they're not designed to be very tamper evident at all, because tamper evidence is like the enemy of easy manufacturing and cheap manufacturing. So people want cheap stuff. Yeah. So the problem is we need to convince people that they should be worried about this in advance of having a problem and sort of implement these policies earlier on.
Yeah. Operational security is not retroactive. You've got to be doing it at the beginning or something bad is going to happen down the line.
And so we've got some areas for research, other people or us or whatever. So a major area of this is actually policy, knowing that you need to do this or that it is a threat, that physical attacks are a threat, and that you need to do countermeasures. Computing devices that are designed for better tamper evidence and response, maybe a computer that doesn't have a bunch of ports on it and a bunch of direct DMA access memory ports external to the system and things like that would be nice. Better ties between the seal technology and trusted computing technology. So I sort of wrote off the TCG trusted computing stuff from a physical perspective, but it turns out if you combine that with seals, you can actually get some pretty good protection that you wouldn't get with either alone. And integration in an organizational environment into things like your VPN system, your mobile device management, network access control. Because if this is like a little separate system that doesn't really touch the rest of your systems, you'll ignore it and it won't actually use it. But if you tie it into your VPN, so you only get access to your VPN when the seal check is verified, only get access to other resources that way, it'll work really well. And the seals we're using are not really designed for this. They're sort of, we're reusing seals. The sensor platform we have is a cell phone that has it's a decent camera, but not a great camera, especially for macro type stuff. And a lot of the seals are designed to be inspected by humans visually at like a very forensic level. So it would be nice to have seals that are designed and optimized to be better sensible verifiable by a phone. And maybe other kinds of thing rather than visual. So a bunch of stuff like that, and I'm sure there's other areas of research that are appealing as well.
So in conclusion, we're now realizing that there's a much wider variety of users at risk. It's not just government entities, intelligence communities, but it's basically everyone in this room. New technical solutions are needed. Most of the knowledge base is kept up in those organizations, and there's not a lot of that publicly available just yet. There's a lot of people that are amateurs playing this game, and some professionals. And at least where I'm from, I know most of them. And there's not enough of them to go around to start teaching everybody. And also, remote verified seals are a great solution because then you have a networked resource that can do a little more verification than the person locally can do, and also can cut them off from access. And then also, it's slightly complex enough that you may need a little help just to get started. And so, there's other than just putting seals on there, but having a good baseline of policies and procedures. So anyway. That's our talk. So we'll open up the floor for a few Q&As. Christy. Yeah.
Hi. Okay. Yeah, we have time for questions. Please line up at the microphones. We have 4 microphones. I can't tell, are there microphones up top? And we're also taking questions from the internet. So if you're watching our live stream, haven't made it to the Congress Hall yet, please, we are taking from Twitter and IRC. So let's get started. How about microphone 2?
Hi, less a question and more a very brief story about physical access that I'm pretty sure even you probably haven't heard of. I work at a robotics company. The company runs mostly on interns and visiting researchers that come and go. And this actually happened. One of our interns, we had him over for a semester, and for a semester, great break, did some great work, decided to have him back, pulled his physical access, his HID key, pulled his other access, but because this is an academic environment, you want to encourage collaboration while they're back at their home university, didn't pull the VPN keys.
Oops. Oops.
Have him back for a second term, and he gets there all bright, and he's a very young, industrious intern. He gets back for his first day of his second term, all bright-eyed and bushy-tailed, and realizes, hey, he doesn't have door access yet. But he does have his VPN keys, and he's sitting outside the building, and so he pops open his laptop, VPNs into the internal network, SSHs into a robot, drives the robot over to the door, and runs the door opening program from the inside.
Yeah, it sounds like I want to hire him.
And actually, we checked this. There was because it was from the inside, there was no record in the HID logs.
Yeah,
and there
often
is
HCL doesn't do that.
Only an SSH. You can only tell he started a VPN session. There's no logging of like what machine he VPN'd into, because the robot is basically a little Linux box on wheels.
Yeah, interesting follow-up to that, and that's a great story. Thank you. That's very entertaining. Yeah, a lot of companies they don't link their VPN with their other credentials and systems. Like if someone's desktop fires up, but they didn't walk into the building, and they're supposedly there, but they're not. The CTO and the CSO don't actually talk to each other often, so there's a lot of problems with that. So as an example right there, you don't have exit control access logs, and also you're not logging the robots. So interesting use case, but yeah, that is a big problem.
Okay, I understand we have a number of questions from the internet.
There's just one really at the moment.
Oh, voice from above.
Question from IRC. Are you aware of any open source hardware security module or something that you could build yourself?
Ryan, you can take that.
ShmooCon in about a month. I'm doing a presentation on that. There actually are 4 or 5 projects to do something like that. One from DNSSEC. There's a few. People have used like Raspberry Pis. They've used various other devices. They generally focus on separating out they focus on the logical protection as opposed to high-end physical protection. But ultimately, I think the best way to do an open source HSM is to publish a great design that can use commodity components, because it's really hard to tell if a IC has been compromised. But if you can use a variety of cheap commodity components, you can put them together, you can buy them from various sources and do stuff like that. So yeah, there's some interesting work in that area that will be open source and public.
Okay, microphone 4.
Hello. I have more request, not exactly a question. Could you please show again the slide where you compared those two photographs? Because I didn't see anything.
Oh, sure. Yeah, it's hard on the screen because I don't think it is a 1080p and it's not very bright. So I'll stand right over here, and I don't have a laser pointer, but it's that screw.
Oh, sorry.
And now I'm going to have a seizure. That screw right there, can you see it? You might need to get closer. That's the thing. Like, when blown up with this contrast, it's really hard. But when you actually look at your laptop screen, it's very easy to tell. So again, walk closer to the screen. You'll definitely see it. But that's the thing. The point was, it's a very minute detail. And if you aren't vigilant, and if you're just taking notes or something, that's practically useless. I mean, you're just really going to go on the side of error that something happened instead of actually having proof.
Okay, thank you.
You're welcome.
Okay, microphone 2.
The description said something that you will present something about physically unclonable functions for hardware tamper detection, if I understood it correctly. Would you mind elaborate on that? What results you got there, and what kind of protection you can achieve using that?
Yeah, so we did, because of the time constraint of the talk, we pulled out 2 slides, and one of them, aside from physical unclonable functions, which are, like in our context, my context for work is, devices with unique characteristics of manufacturing. We'll actually put it up in the slides on the way out when we upload them. We had two changed batteries, so we had the same laptops and the identical batteries, but when you swap them, and they were from the same line, you could easily tell back and forth which things are changed. So if someone swaps out a component, it turns out through plastics manufacturing, even milling, they'll look slightly different. But it's hard to tell visually side by side, but if you do a quick blink comparison, you can tell. And the same thing like the stickers. The stickers themselves are puffs. You might be thinking more of the ones at chip level, but this is more macro. Yeah. So
and we've also done non-sticker seals, basically paint, special paint. Dynamic things like metallic paint, glitter, things like that. Yeah. Those are also a form of physical unclonable function. There's also the array of fiber optic cable where it's sort of randomized. Really anything where you physically can't copy it in the manufacture time, where there's randomness in the physical manufacturing process. Mm-hmm. The technique of verifying and doing remote verification works just the same with those. We can't do this with like chips because we don't have an electron microscope on our cell phone right now, but we can do this for
soon.
The goal is to be able to do it. The sensors that will work with the phone, so we have to do macro level type stuff.
Okay, so it's not about smart cards with physical unclonable functions. It's just physical changes which you photograph with your cell phone.
Device level things, not chip level.
Yeah, further up the chain, they're both physically unclonable functions. They're just at different scales.
Okay, then I would have a follow-up question if
Sure.
I can.
Yeah.
How does it actually work in practice? Because you leave your hotel room in the morning, you come back in the evening, you have different lighting conditions, you cannot put the cell phone into exactly the same position. How does it work in this scenario?
I'll take that. That's actually really easy to do. You close the shades, turn the lights on so you have a consistent lighting condition, and that you put your mobile device or camera device in a jigged format. So you find a surface that you can butt your camera up to and lock it. So you, like a shelf, push it against the wall, stand to the side, take a photo, and almost every single time it'll be identical, and then you can correct it on your laptop or other devices and just overlay them and then flip them back and forth. You can use like for Macintosh Preview, and like actually I don't use Windows. So
yeah, there's also registration marks that you can put in the image to assist it. We have some not very great OpenCV code right now that tries to do this. Yeah. Which will be open and released. You can put registration marks in to make this process a lot easier. The problem is you have skew and stuff on the camera, so it's actually a fairly complicated problem, but it mostly works.
Yeah, there is a product in the iPhone store that does blink comparison. The problem is it's very inaccurate because it wants you to hold it, and a human is not going to be able to replicate the same parallax for your shot every time. It's going to be slightly off, and it's going to be very. I've used it. It's not very great. And so, as I said, like basic things like find something in the room that's immovable that probably hasn't moved. The desk may have moved, but find something that's nailed down like a shelf, and then you can just do that shot, and you get it very reproducible.
Yeah, and if you have and certain kinds of seals are going to be much easier to verify than other kinds of seals. They'll have large areas.
Thank you for the question.
Okay, do we have a question from the internet?
Yeah, another question from the internet is, how would you make your own seal? And if you were to get a seal, what would you be looking for into a good seal?
So a good seal, you want something that's easily frangible, but it's not going to break by accidental use. I don't want to give away all the traps because then that gives my adversaries an advantage. But a good one, which is easy to use, is pearlescent paint or nail polish. Put it on all your screws. Take a photograph. Specifically ones that have a lot of glitter in it, because it's going to be very difficult to replicate that.
Yeah, there's really two big classes of attacks. There's taking an intact seal, removing it from a device, tampering with the device, or tampering with the device without breaking the seal, and there's counterfeiting the seal itself. Conventional seals, a lot of cases, depend on like mass manufacturing being really hard, and quantity 1 costing the same as like quantity 10 million. That's not so much true anymore with a lot of manufacturing technologies. I can copy something pretty easily. So I take your device that's protected by a seal, cut the seal up, destroy your seal, and just make a new one and put it back on, and you won't be able to tell. That's a threat, but certain kinds of things like the glitter are going to be very difficult to do that with.
And it's incredibly cheap, too. And it looks pretty.
Yeah, and cheap is a major problem. Also needs to be fairly durable because you don't want it to break in incidental use. There's some tricks you can do to help against that, but yeah.
Yeah, so like stickers, like cheap, crappy stickers. One of the things we've been coming up with is actually time decay stickers, where when you sync it with the VPN service, you apply the seal, and the color will fade away. And when you take it, the system, of course, will know what the general decay should have been. So someone will have to have like 100 or 1,000 seals prepped over time, consistently fading, to know to get it at the right time. But also, if they could time out or not get the right one after 3 tries, and then you know that you won't be able to get back in the system, and that's a good thing.
Okay, microphone 4.
Hi, the discussion you just had reminded me of a paper from Princeton University, I think from last year, about pieces of paper. And they found that pieces of ordinary paper were actually more at the microscopic level, quite physically distinct from each other.
Yeah,
and that I think an ordinary scanner was able to reveal patterns of wood fibers in the paper that were distinct from piece of paper to piece of paper to piece of paper.
I believe that.
And that was quite scary from a privacy point of view, because, for example, the company that makes the paper could actually have internal serial numbers of the sheets of paper that they sell.
It's like banknotes or your printer cartridges.
So I guess from a seal's point of view, I wonder if, with a sensor that people might have, if you could actually use maybe sheets of paper and the wood fiber patterns in them as a physically unclonable function.
That is definitely a legitimate method. Yes, that is a legitimate method. Though having a flatbed scanner with you on your trip, it seemed a little more unlikely. So we do our best to find ways to use the tools available to you currently.
So
but you can do that.
Do you think there's a prospect, I don't know what level of magnification you need, that the cameras in phones at some point soon might actually be able to get some of that patterning under some lighting conditions?
Yeah, definitely. If you had one of those external little like $30 macro lenses on your camera, you'd be pretty well served there.
Yeah.
We can look at this. It actually looks like an interesting thing.
Yeah, actually, send us an email. We'd love to chat more about that.
Cool.
Yeah.
Okay, do we have one more question from the internet? No, okay.
All right.
Sounds like we're all good.
All right, well, guys, thank you again. Thank you for having us.